This is the fun one. So this is where you actually see the applications of logarithms of exponential functions, but they call it applications of logarithms. Most of these problems you're going to be able to figure out. Just make sure you read the question closely. The questions will tell you what everything means. These are kind of the only two that don't tell you what everything means, so I wanted to make sure that I go through those with you. So let's just jump into it. We'll be done in 5 minutes just like the last one. Yeah. So we have George put 1,300 in the bank for 6 years with an interest rate that is compounded monthly. So I see this compounded monthly. I have my formula right there. But if it's compounded monthly, that tells me n equals 12. 6 years, there's my time. There's my principal, because that's how much he put in. At the end of the 6 years, he had 1457.81. So that is actually my after amount. So what was the interest rate in his account in order to get this much money? So if I put in all my numbers, 1457.81 as my A, P is 1,300, 1, so 1 plus R, which I don't know, over N, which is 12, all to the N times T power. So let's simplify our numbers a little bit, but I also notice that I have this 1,300 on the outside. So what I can do is go ahead and divide by that 1,300, save myself a little bit of time. So I have 1457.81 divided by 1300, which will give me 1.1214. Going 4 decimal places just so I'm not off by as much. And then I have 1 plus R divided by 12 to the 12 times 6 is 72. So now, I'm kind of stuck, aren't I? But I don't need to rewrite this in exponential form or logarithmic form or anything like that. It's not even actually in exponential form. My variable is right there. My variable is not in my exponent. So what I would do here is it's kind of like solving when we were doing it with roots and exponents. So if I take the inverse power, the 1 over 72 power, this 1.121 will become 1.00159 equals 1 plus R over 12. Cool. So that gets rid of my exponent, right? So then just subtract the 1 from both sides. So minus 1, minus 1. So I have 0.00159 equals R over 12. Then you guessed it, just multiply by 12 on both sides. So I have this 1, it's 12. So I'll get the rate was 0.0191. Which if you wanted to write it as a percent, don't forget to move that decimal twice, so it's 1.91%. Cool. All right, the next one. These are a little bit more good example. They were talking like finding a burrito in the warehouse. So I used a burrito. A burrito was found at 11 a.m. in a warehouse where the temperature was 45 degrees Fahrenheit. The examiner found the temperature of the burrito to be 64 degrees Fahrenheit. What was the temperature, approximate time the burrito was put in the warehouse? Use Newton's law of cooling with K equals 0.01947. So they give us this equation. That's Newton's law of cooling. They don't have any of this information for you in the quiz, so make sure you get that down. T sub A represents the ambient temperature. All that means is the room temperature. T sub 0 represents the initial temperature, and T of T represents the temperature at any given time. So if I put in everything I know, right, this is the temperature was 45 degrees for the warehouse. That's my ambient temperature, so I'll put 45 plus, the examiner found the temperature to be 64, so that was my final temperature of the item. What was the approximate time? So I don't know T of, I don't know T. So I don't know that. That's what I'm going to be looking for. T naught was the initial temperature. I didn't write it in the problem, I'm sorry. Let's say that burrito came out hot and steamy at 120 degrees Fahrenheit. It's going to burn your mouth. So 120 minus the ambient temperature, which was 45, e to the negative k, which is the point 0.01947 t. All right, so there's all of our numbers plugged in. So now we're just going to be solving this thing. We are solving for t, so we're solving an exponential function. So if you need a refresher on solving exponentials, go back 2 videos, but I'll walk you through all of it too. So the first thing I would do, subtract 45 from both sides. So minus 45 minus 45. So that gives me 19 equals 120 minus 45 is 85. So 85 e to negative 0.01947 t. Then that 85 on the outside needs to be divided. So divide both sides by 85. So I have 19 over 85 equals e to the 0.01947 t negative. So now I'm stuck in exponential form. So I need to rewrite this in log form. Wow, this video is already longer than the last one. Dang. So base e, so natural log then, because natural log's base is e, of the other side. So 19 over 85 equals my exponent, so negative 0.01947 t. I'm going to type that all in the calculator, and then I will divide everything by this negative 0.01947 to get time by itself. So, typing that in. ln, 19 divided by its times, divided by 85, and then I'm going to divide that number by that negative 0.01947. So I get 76.95. So that burrito was in there quite a long time. So t equals 76.95. 76.95, and t is actually being measured in hours in this case. So that burrito's been in there quite a while. Didn't realize it would take that long for it to cool off that much. Unless that's minutes. It could be minutes. I don't know. All right. Either way, let me know what I can do to help you guys out. I'll talk to you all soon.